So just let me know once you're able to see my screen.
Yes, I'm able to just see the screen.
Perfect. Okay. So let's not talk about today's topic. Let's just discuss what we have studied so far. So far we know how to find the value of x whenever you have a question of this type. Whenever you have f of x equals 0, for example, you have x squared plus 2x equals 0. So you know how to find the value of x. We have been discussing that already, and we know that from A level or from O levels as well. Okay. Then in this chapter, we have discussed how to determine if there would be a root between an interval. Let's say this is my interval. So in this chapter, we have seen that how to determine if there would be a root between this interval. And what was that method? So A is one limit, B is the other limit. I simply have to find f of A and f of B. So if there is a sign change, let's say this value is positive and this value is negative, or it's other way around, this would imply that yes, there is a root. And then we also discussed some of the exceptions, like in case of tan, we saw that yes, we had a sign change, but there wasn't any root. Okay, so we know how to find roots. We know how to determine if there would be a root or not. But today we are going to talk about another method that is called iterative method, and this again is used for the same purpose, for finding the value of x. Okay, so let's just rub what we have discussed already. Are you clear with all the old stuff?
Yes.
Perfect. Okay. So okay, so let's just see what iteration exactly is. Okay, so iteration is repetition of a process. Okay, and the other thing which you need to know is we do iterations in order to solve f of x equals 0. Okay, so by now we know how to solve f of x equals 0. And when I say solve f of x equals 0, it means that if you have an equation of this type, you need to find the value of x. This is what solving means. And we know how to do that, right? So far, we know that if it's a linear equation, we'll simply make x the subject. If it's a quadratic equation, we will either make factors or use that quadratic formula and stuff like that. But here, we need to use iterative methods. Okay. So what are iterative methods? Iteration is repetition of a process. When we'll be solving questions through this method, you'll see that we'll be repeating the same process. Okay. What process would it be? We will discuss that. And the second thing which you need to know is that through this method, we are basically solving f of x equals 0. So here again, we are finding x, where our function is 0. Are you clear with the basics of this topic?
Yes.
Okay. Now the question is, okay, we understand that what iterative methods are and why are we going to use it and stuff like that. But the question is how to use it. This is the question. Okay, let's talk about this now. So initially, you need to arrange your function in this form. Right, okay. So basically, whenever you come across a question, where they have asked you to find the value of x through iterative methods. And they certainly would mention this because in mathematics, this iterative method is not something anyone would prefer because it is time taking. But yes, this can certainly come in your exam and they would tell you to do it through iterative methods. Okay. So whenever you have a question in this form, let's say x squared plus x equals 1, stuff like that. So you need to arrange it in this way. And how will you do with that? You will do that by simply taking this one on this side. So this is the form the examiner would expect from you initially, okay? And now our major working would start. Step 1. Step 1 is to get g of x equals x form. Now, what is this form? Okay, so initially you will have this form, and for using the iterative method, you need to make this form. How will you do that? It's very easy. Let's take again x squared plus x plus 1 equals 0 as our function. Okay, so this is basically f of x equals 0. And they want you to get this form. What is this form? G of x equals x. So it would be 1 minus x squared. This is x and this is g of x. So basically you are writing x in terms of x, right? Okay. Another way of doing this could have been, you could have done this way as well. X squared equals 1 minus x. Now you simply take under root on both sides. So this could also be your x equals g of x form. So this would vary and we will discuss this today in the next section. Okay. So far you need to just understand how to make this form using f of x equals 0. Are you clear with this?
Yes.
Sure.
Okay, can you repeat it once more?
Definitely I can. Okay, look. So this is an example, okay? I will give you a proper example once we do a question. It's just for your understanding right now. I am saying for solving it through iterative methods, what iterative methods are? When you are solving for f of x equals to 0, okay? Here your goal is to find the value of x, okay? And we are doing that, okay? Step 1 is to get g of x equals x form. Now, what do I mean by this? By this, I mean, if this is your f of x equals 0, and this is your example where we particularly have x squared plus x minus 1, I will tell you how to get g of x equals x form for this. Okay. First, you need to understand what is g of x equals x form. So in this type of a form, you will play with this type of an equation and you will transform it such that on one side you will only have x and on the other side you'll have all the remaining x's, x squares, x cubes and things like those. Okay. So here we had x squared plus x minus 1. We need to make it the g of x equals x form. So this means we need x on one side and the remaining things on the other side. This g of x is basically the remaining stuff, okay, which would have x. This is why we have g of x. Okay. So this is x squared plus x minus 1. And one way of getting this form is by basically writing this x here and taking this minus 1 and x squared to the other side. So isn't it the x equals g of x form? We have x on this side and we have the remaining stuff on the other side, right? Okay. And the other way of making this form could have been that you play with this x square. You take 1 and x to the other side and you simply take under root on both sides, so you will be left with this. Now you can clearly see that both of these are x equals g of x equals g of x forms, but they are different, right?
Yes.
So you understand how to make this form.
Yes.
Perfect. So what if, oh, let me ask you a quick question. So we are clear. What if you have x cubed plus 4x minus 8 equals 0? What would be your one possible g of x equals x forms? Just tell me, I'll do it here. So I can take this 8 and x cubed to that side. I'll be left with 4x. This is 8 minus x cubed. And I can divide this 4 on both sides. Now clearly I have x on one side and this is my g of x. So this is my x equals g of x form. So is it clear now? Is it clear? I can't hear you. Yeah, is it clear?
Yes.
Sure?
Yes.
Okay, perfect. Okay. So this is step one. Okay, step one is to get this, and step, we only have two steps. Step two is to use the iterative formula xn plus 1 equals g of xn. Now what is this? Okay, don't worry. Here we got this g of x equals x. The only thing you need to do is add n plus 1 here and add n here. Now what this exactly is, you'll get to know shortly, okay? The only difference in step 2 and step 1 is that this, here we have written n plus 1 with this x, and here we have n with this x, okay? So you should know this iterative formula. So did you understand?
Yes.
Sure?
Yes.
Okay. All right. So let's talk about an example. You will get to know everything. You will understand everything once we do this example. So just don't worry. Okay. Let's keep the rough working here. We might need it. Okay. So example number 1. Show there is a root in the interval x greater than 7 less than 8 for the equation x square equals 7x plus 3. Now we have discussed this already. You know how to show root, right? So how would you do that? I want you to do it for me.
You
Okay,
substitute 7.
very good. But first you need to make f of x
Yes.
0.
You have to get everything to one side.
Very good.
X square minus 7x plus 3
My,
equals 0.
yeah, like this, okay? It would be minus 3 when I'll take it to that side.
Yes.
Now I need to plug in 7.
Yes.
This is clearly minus 3. And now I have to plug in 8. This would be 5. This is negative. This is positive. Hence,
That means there is a root
yeah,
because
but you
of
need to write this.
sign change.
Yeah. Hence, change of sign implies that there is a root between f of 7 and f of 8. Okay. Okay, so we are clear with the first part. Let's talk about the second part now. Okay, now we know that there is a root, but the question would be to find the root using the iterative methods. Okay. All right, so the second part is show that x square equals 7x plus 3 can be written in form x equals 7 plus 3 by x. So can you see through second part that we are going in the same direction? This is x and this part is g of x. So here they have
Yes.
asked it as a separate part, but when they will ask you directly to use the iterative method, this is something they would assume you to do it directly, okay, without any parts or without any guidance. This is the method and you should know it directly. Okay. So here let's move step by step. They are saying we need to show that this is basically this. Okay. So how would you do that? You simply need to take this is x into x. So you'll take 1x to the right hand side. You will get x by x basically. Let's do it this way. Just think of it as if you are dividing an x on both sides. In maths, we can do anything, any similar operation on both sides of the equation. It's mathematically correct. Okay, so this would be x equals 7 plus 3 by x, right? So hence we have shown that this is basically this, right? So we are clear with this as well. Okay,
Yes.
perfect. Now comes the new thing. Do you have your calculator with you? Because we'll be using calculator here.
Yes, I do.
Okay, perfect. The third part is the main part. Find the root of x square equals 7x plus 3 in the interval this 2, 3 decimal places. So you need to look after two things in this section. Number one, decimal places, and number two, appropriate use of calculator. Because when we are dealing with decimal places, we need to use calculators, okay? Because you'll see we'll get big figures and we need calculator for that. Okay. So this is where we will apply iterative method. So step one was to get the x equals 0 of x form, right? So if this is my function, obviously you need to do this in order to check if there would be a root or not. We have done that already, okay? So let's just move to the first step directly, which was to get x equals g of x form. And we have already done that in previous part. It was x equals 7 plus 3 by x, right? We have done that. Okay. So this was step one. And step two was to write x n plus 1 equals g x of n. Okay, now what does this exactly mean? You have n plus 1 here, so you will write x n plus 1 here, and here wherever you had x, you need to replace it by xn. Do you understand so far?
Yes.
Perfect. Now you need to understand one thing. So basically, in these methods, you will do repetition of a process, and what that process is. You will start off by x naught, and this is something I'll tell you later. Okay, this is something which you would either be given, or you will choose this as your x naught. Either you would be given with your x naught in the question, or you will choose this 7 or any initial limit of your interval as x naught. Okay. Once you have your x naught, you can always find x1. How? If this is x1, n would be 0. If n is 0, this would be x naught. So this would be 7 plus 3 naught. Did you understand this? Think of it like this. You will understand
No,
this now.
can you
Oh,
repeat
sorry.
it?
Yeah, okay, definitely. I will. Okay. So basically, we are going to use iterative methods, and I told you initially that in iterations we basically do repetition of a process, and this is what we are going to do. We started off by x equals dx. We got this formula. You're clear with this. Now we will first find x naught, x1, x2, x3, so on until we find a root. Okay, until we find our root. Okay. Now there are multiple things which you need to understand here. Number one, when are we going to know if this is our root or not? And what are these x naughts, x1s, and x2s? Okay. Just skip this x naught for a second and think about x1. How can you get x1? You need to use this formula. How are you going to use this formula? If this is xn plus 1 and you need x1, n would be 0, right?
Yes.
N would be 0. If n is 0, this xn would be x0. Do you agree?
Yes.
You'll just understand. Okay, if I want x2, I can write x1 plus 1. This would be 7 plus 3 by x1. So you see, initially we will somehow find x0. Now we will use this x0 here to get x1. Then once you have your x1, you will use this x1 here to get x2. And similarly, you will use x2 where? So we have to find x3, that is 2 plus 1. So this is going to be 7 plus 3 by x2 equals x3. So you have used x2 in order to find x3, right? And this is n. This is n.
Yeah.
This is n. Do you understand?
Yes.
Not 100%, but at least somehow, somewhat.
Yes.
Okay, perfect. All right. So we need to basically apply the method now, and we are clear with how to apply. Okay, so we need space, so I'll rub everything. Okay. Now the question is that we need to find x0, x1, x2, so on, such that we end up at our root. And this is why we use this method. Okay. Now you need to understand multiple things. Number one, what would your x0 be? Because once you have your x0, obviously you will get x1, x2, and so on. Because in x1, your previous x, that is x0 or x0. Okay, x0 is also called x0. I'm sorry, I'm using x0. You will understand with x0. Okay, so once you have your x0, you will use it in the formula and you will get x1. Now if you have x1, you will use it in the formula and you will get x2. So you know how to go to your root. Question is what your x0 would be. Okay, So there are two things. Either the question would, either the examiner would tell you what to use as x naught, or you will use this initial limit of your interval as your x naught. So here, since we have not been given with any x naught, so what would my x naught be, Anjali?
7.
Very good. So I need to use x naught as 7, and my formula was xn plus 1 equals 7 plus 3 by xn. So you understood this clearly, right?
Yes.
Okay. Now we need to find x1. x1 is basically 7 plus 3 by x0. This is 7 plus 3 by 7, right?
Yes.
And this would be 7.428. Okay. Never ever write it to 2 decimal places or 3 decimal places, especially when you have been given with 3 decimal places. Okay. And okay, I'll tell you in next step. Now we need to find x2. X2 would, I want you to tell me the formula for x2. It would be 7 plus
7 plus
3 by x naught, or x
3
by x.
x
We have 2 here, so this would be 1.
x2.
x1.
Okay.
Why?
Okay.
Because we
X.
have found x1 recently. We will use this recent value in our next value. Okay?
Yeah.
Okay, so this would be 7 plus 3 by, what would be the value in x1? This value. This is
Okay.
7.428. You will understand it. This is very easy. Okay, don't worry. You will understand it. And you need to use your calculator. Just use your calculator and tell me the value which you are getting.
The value of 7.4.
Exactly. This is what
7.
I just said. Use this, and now tell me the value. There would be a minor change, but still you need to write down the whole value, okay? Not just till 3 decimal places. Even here you have been asked to find the root till 3 decimal places, but still you need to write the exact value. And this is why use of calculator is important. So you will get
7.40384623
2.
232.
Very good. Okay. Now I'll tell you. Now it's a big value, but you will use your calculator. Do you know that answer method of calculator? Like, you know, the
Yes.
7.403846238 would be stored in your answer. Okay. Okay. Now be very careful with your calculator. This is x2. You need to find x3. For x3, your formula would be 7 plus 3 by.
7 plus 3 by x2.
Excellent. And now in your calculator, you will do 7 plus 3 divided by answer. You will not write down this whole thing again. So tell me the value which you are getting.
7.405194801.
Perfect. Okay. And in the similar way, if you find, can you please find x4 for me and do everything and tell me the answer? Just see if your answer matches mine. Yeah, I'm writing it. Okay. Now tell me, is this what you are
Yes.
getting? Okay, perfect. Now, why did we stop?
512101.
0 1. Okay, perfect. Okay, it's okay. Why it's okay? Because we need to find till 3 decimal places. And the thing which you need to see is that here I got 7.3405, and here again I got 7.305. And you can see that your answer is not changing. It is changing, but after the in the later decimal places. Okay, the later part has changed, but till 3 decimal places your answer is same. And this is where you need to stop. This is your hint, this is your clue that your root or your x is 7.405. Okay, so I'll tell
Yeah.
you, I'll repeat everything. Okay, so here you need to find the root. Okay, we know how to find the root through multiple methods. But in exam, if the examiner wants you to do it through iterative method, you can do it. Okay, what is an iterative method? It is a repetitive process. By repetition, we mean that we will be doing a similar thing again and again, and you have seen how we are doing it. Okay, so you will basically start off by x naught, you will find x1 and so on, and you will go till your root. So we have two questions. What is our x naught? What is our root? And how will we find x1? So x naught or x0 would either be given. You will see in the next example, the examiner or the book has basically told you to use x naught as a particular number, or if you are not given, you need to use this first number as your x naught. Okay, so are you clear with x naught?
Yes.
Okay, now once you have your x naught, you need to use this formula. Now what is this formula? This formula basically is that, you know, the first step is to write down this value, this form. Once you have this form, you will simply write xn plus 1, and with every x, you will write xn here. Since you have x0, you can find x1. Okay, in x1, x0 would be used, in x2, x1 is used. So you can see that in every number, in every x, n plus 1, the previous xn is being used. Since you have x0, you will have x1. Since you have x1, you will have x2, and so on. And you have to stop where you see that your number is not changing till a particular number of decimal places that would be given in your question. Is this clear?
Yes.
100%?
Yes.
I can repeat it again, okay? It's not a
No, it's
problem.
fine.
Okay, perfect. Okay, so let's talk about another example. Okay. Let's just use a new board. Okay. So we have example number 2. Show that x cube minus 5x square minus 4x plus 7 equals 0. Show that this equation can be written in the form x equals a plus b by x plus c by x square. Okay, so this is your question. And the first part is just to show that this equation can be written in this form. So this is quite easy, right? Okay, let's do it together. Let's just write down this equation again. Okay. Now let's just take everything to that side. This would be 5x square plus 4x minus 7, right? And let's just divide x square. Let's just take, this is x into x square because it is x cubed. Let's just take that x square to the right hand side. So since it is being multiplied here, it would be divided on the other side. So it would be 5x square over x square plus 4x over x square minus 7 over x square. So this is basically 5 plus 4 by x minus 7 by x square. So did you understand this?
Yes.
So A is 5, B is 4, and C
4
is minus 7.
and 7.
Okay, so this was easy. All right. Let's talk about the second part now. Okay. This was the first part, and the second part is use use an iterative formula to find an approximate solution of the equation to 2 decimal places with x naught equals 1. Okay, let's do the second part. But before doing it, we need to understand the question. So you need to find an approximate solution of equation. I have told you that solution basically is to find the value of x, right? Whenever you have f of x equals 0 and you have been asked to find the solution, you basically have to find the value of x, and that value is basically the root. Why? Because at that particular value, the value of function is 0. Okay. Okay.
Okay.
Okay. So we know that we have to do something which we have been doing, but this is the game. You need to use iterative formula. Okay, let's do it again. Okay, so we have our first step. Step 1 is to write x equals g of x form. And the purpose of doing this part A was to basically find this form. So we had x equals 5 plus 4 by x minus 7 by x square, right? So we have our x equals g of x form. Step 2 is to basically write it as an iterative formula. X, instead of x, we will write xn plus 1, and instead of x, we will write x. Yes, Ranjani?
Yes.
X what?
X1.
No, no, no. Here we are writing the general
X0.
formula. This is the general formula. This is n here. Now we have n here. So, sorry?
XN.
Excellent. Xn minus, and we will have
7 by X.
Yes, you need to replace xn by x simply. So it would be xn whole square.
Square.
Okay, I'll tell you. You are clear with this, right? You know how to get this. Once you have this, you simply need to replace this x by xn plus 1 and the x's on right hand side by xn. This is the rule for right hand side and this is the rule for left hand side. And the underlying assumption is your iterative formula. The fact that you will use x0 for x1, x1 for x2. So this is why this is 1 plus n and this is only n. Okay. Okay, so this is clear, right? Okay, now let's apply it now. So once we have our formula, we need to start our game with first we have to have x0, x1, x2 till our root. So I told you for x0, either it would be given or it would be the first or the initial limit of your interval, right? So what is the case in this in our example? We have been given. They want us to use x naught equals 1. So we will take x naught equals 1 and x1 would be, I want you to tell me what would be my x1. It would be, use this formula. Use this formula. It would be 5 plus 4 by when we have x1 here on the right hand side, it
Be
would
at 0.
very good. Minus 7 by,
0 square.
so this would be 5 plus 4 minus 7, right? Do you agree?
Yes. Yes.
Perfect. So this is 2. Okay. Now x2, what is the formula for x2? 5 plus
2
4.
will be 5 plus 4 by x1
Very good.
minus 7 by x1 whole square.
Excellent. So it would be, just tell me the answer directly. Use your calculator.
Yeah.
Would it be this?
5 plus
Take your time.
5.25.
Very good. Okay. So we have x2. Okay, let's talk about x3 here. x3 would be 5 plus, and use this as answer. Okay, use your calculator. 5 plus 4 by, you will use x2 and your x2 is basically the answer button in your calculator, right?
Yes.
Minus 7 by,
5.5079.
very good, excellent. So this would be 5.5079. I have 37 as well. Okay, use the exact value because in calculator you will be using your answer. So obviously you will be using your exact value, but and for showing the solution, you don't have to do it for every value. Okay, you'll see after x3, I will directly write down my x4 and you will tell me the x4. What x4 are you getting? Let's see.
0.49.
Very good.
Oh, okay.
5486. Excellent. Okay. And x5, it would be 5.496085. Okay.
84. Okay, yeah.
Okay, yeah, okay. If that's okay. So now tell me, we have our clue, we have our hint here. We can clearly see that we were asked
4.
to find exactly, excellent, two decimal places, and we can see that our value is not changing. So our root, that basically is x. Okay, do not use the word root. Use x. So x is 5.49, right?
Yes.
Okay, but there's a thing. 5.49 is basically our alarm or something which we can use as our, stopping, as something which is telling us to stop. But when you have to write it to two decimal places, this would basically be 5.50. Okay, not 5.49 because we have 6 here, right? Okay?
Okay.
Did you understand this?
Yes.
Sure?
Yes.
100%? Tell me honestly.
Yes.
Because we
100%.
will, okay, perfect. So let's talk about our second section, last section of this chapter, that is 6.4. Okay. So it says how iterative methods can vary. Okay, now you need to you we will see that how, and I told you initially that this is something which I or any examiner or mathematician would not prefer, because this gives us an approximation and this is time consuming. And if we use iterative methods, our answer might vary. Okay, so because of these few reasons, this method is not preferable. But definitely, if you have been asked to do it this way, you have to do it this way. Okay, you cannot say that this method is not preferable, so I will not do it this way. Okay,
Okay.
let's discuss it by an example. So the first example for this section is okay, so right. Let me write down the question. Okay. So the question is x square minus 7x minus 3 equals 0 can be written in the form x equals 7 plus 3 by x. Okay. So you need to show that it can be written in the form x equals x square minus 3 by 7 as well. Okay. So can you do this part? So let's do it together.
Yes.
Solution. Okay. So they're saying that one way of writing the x equals g of x form is this. I told you in the very beginning that, where I gave you an example that, okay, this can be x equals g of x for one example. But yes, I also showed you another example where we had a different form, right? Okay. So let's see if we can get this form or not. So we have x square minus 7 x minus 3 equals 0. So clearly we have 7 here. So we need to keep the 7x over here. And it would be x square minus 3 equals 7x. And I can divide the 7 on the left side to get this. And this basically is x equals x square minus 3 by 7. So we are done with the first type, but you need to see that both of these are x equals c of x forms, okay? I hope that's clear.
Yes.
Perfect, okay. Now the second part is the basic concept, where you will see that how iterative methods can vary. By now you know that x equals g of x can change. Okay, we know that. But let's say that if we have a different form, would that end up as a different root? Okay, so the second part is show that the iterative formula xn plus 1 equals 7 plus 3 by xn. And so this is what they had given already in the previous part. And this is what we did. Give different roots of equation to one decimal place when x naught is 0. Okay, so this is our question, right? Okay, let's read it together. So the question says, show that the iterative formula this. We got this iterative formula for the first x equals g of x type in the previous part, which was given. And this xn plus 1 equals xn square minus 3 by 7. This iterative formula is basically coming from the one which we made in the previous part. Okay, so we had two x equals g of x forms, so we will get two iterative formulas. And what we need to show is that by using these two different iterative formulas, this would give different roots of the equation which we had in the first part to one decimal place when x naught is equal to 0. Okay. So basically, using x naught equals 3, again it is given. And this part, we will first use this and then this to show that we are getting two different roots of x. Okay. Let's try doing it this way. Let's see if we are able to do it in this much space. All right, so let's use this color. Okay. Solution. So we have, let's use this form first. Okay, so let's use this first. Are you clear with the question?
Yes.
Okay. This is the first, this is the formula. This is the first iterative formula which we'll be using here. So what is the rule? We have to write x naught, x1 till root, right? We know this. Okay. I will not write this, but we know this. Okay, this is how it works. Okay. So what is x naught? X naught is 3. Here we have been given with our x naught, right?
Yes.
Okay, perfect. X naught is 3. So I need to write x1, that is 7 plus 3 by x naught, which would be 7 plus 3 by 3, that is 8.
8.
And x2 would be?
X2 will be 7.375.
Excellent. X3?
7.406779.
Yeah. And x4 would be 7.40.
7.405034325.
Okay, yeah, let's save the ending. But here we need to check till one decimal place. So till one decimal place, we are getting same values. This implies that x is 7.4, right?
Yes.
Okay. Now let's just do it for this as well. Let's use xn plus 1 as xn square minus 3 by 7. So I want you to do it and tell me the final root which you are getting, okay? So I give you 3 to 4 minutes and just do it and let me know if you're able to.
is 0.40. No, this is negative 0.40.
Okay, so you are getting?
Negative 0.40.
Okay, that is perfect. Excellent. Let's do it together as well. X naught is 3. So for x1, you will use x naught square minus 3 by 7. That would be 0.857142, so on. And then you will get x2 as minus 0.3236. I'm putting dots just for now because you have done it correctly, okay? All right, so this would be 0.4113, and x4 is minus 0.4041, so on. So it was one decimal place. We have started getting same number. So x equals minus 0.4 is your root. Now here, the only thing which you need to understand is they're not saying that 7.4 is correct or minus 0.4 is correct. No, this is not the debate. The debate is that if you use different iterative formulas, you will get different roots. And this is why I told you that this method is not an appropriate one. And the only thing you need to observe or understand here is that if you will use a different formula, iterative formula, if your x equals g of x form is different, it would give you a different value. And again, if your x equals g of x form is different, in this case we have different form, so you are getting such a different answer. Okay, so the question was how iterative methods can vary. So we can see that they can certainly vary, and they're varying a lot by using two different g equals g of x forms. Okay, is that clear?
Yes.
Sure.
Yes.
Okay, perfect. We are just left with one question. All right. So now we need to think about something. All right. Okay. So you need to basically think that is there any relationship between the iterative formula chosen and the route to which it converges. Okay, think about this. Okay. Now here, this is not a question. This is just for you. Now here, so far we have discussed questions, and we were lucky enough to see that our answers, or basically our x's, ended up converging, right? Like in the previous example, our x1 was 0.85 something, x2 was minus 0.32 something, x3 was minus 0.413 something, and x4 was minus 0.4041. Okay, so we were lucky enough to see that we got 0 0.4 and 0 0.4. Till first decimal place, our x4 and x3 are same, right? And this is because the values of x are basically converging, okay? But this is not going to happen in every case, and we will discuss that case shortly. But did you understand the question and the logic?
Yeah.
Sure?
Yes.
Okay, perfect. So let's talk about the final example for today. The equation e to the x minus 2 equals 0 has a root in the interval 1 less than x less than 2 full stop by using the iterative formula xn plus 1 equals e to the xn minus 2 with x naught equals to find the root to 2 decimal places. Okay. So let's just read the question and then we'll talk about the solution. Okay. So the example is the equation this has a root in the interval this. By using the iterative formula this with x naught equals 2, find the root to 2 decimal places. Okay. All right. So can you tell me how did they get this form? How did they get this iterative formula?
The first one, they brought x to the other side. So,
Okay.
so x will be positive. So you get e to the power x minus 2.
Very good. So x equals g of x is basically x equals e to the x minus 2. And we know how to get this iterative formula by simply adding n plus 1 to the left hand side and adding n to the right hand side. Okay. Now we have our formula. Perfect. And they have given x naught equals 2. Okay. So the formula which we'll be using is this. X naught is 2. So x1 would be e to the x naught minus 2 That is e to the 2 minus 2. So what is the answer for this one?
E to the power 2 minus 2 is 5.38905.
5.38905.
6099.
Okay, perfect. This is x1. Can you tell me x2? Okay, what would be x2? X2 would be x2 equals e to the x.
To the x minus 5.389.
Yeah, but my question. Okay, perfect. No, why minus? It is simple x0. Okay, so it is e to the x1 basically minus 2. And now you can say that e to the 5.389, and yeah. So what is the value for this one?
E to the power, wait,
E to the power answer minus 2.
yes, e to the power answer minus 2. 216.996.
216.996. Okay. So
5769.
yeah, okay.
It's fine, I think.
5769. Okay. So don't you think that we have done something wrong? Because like this
Yeah,
is 5 and this
the
is
difference
2.
is,
Yeah, so I think we have done something wrong, right?
yes,
Okay, so but before discussing that, let's try finding x3 e to the x 2 minus 2. Just do it again and tell me the answer. You might not be able to get it because it is a big value. Just try and just tell me if you are able to. Are you getting the same value? Are you there? Okay, can you hear me now? Yeah, can you hear me?
Yes, I can hear you.
Okay. So basically we were on this question, and yeah, so x1 is 5.389, x2 is 216, and x3 is this. So basically we concluded that we have done some mistake, right?
Yes.
But the thing is that this isn't a mistake, okay? Since you can see that I told you in the previous question that we were lucky enough to see that our x was converging. This is not going to happen in every question, right? So here, this is a divergent sequence. This is basically a sequence, right? It is a sequence. We write sequences in this way, and this is a divergent sequence.
Okay.
So you will write that this is a divergent sequence. So it is not possible to find the root to two decimal places with x naught equals 2. Okay. So basically, this wasn't incorrect. Okay. I was just trying to
Okay.
confuse you. In previous examples, we could see that our x's were going in one direction. I mean, if we had positive in the first one, we will have negative in the second one, and then we had negative in every next x, right? So things were converging. It was a convergent sequence. Okay, don't get confused with the word sequence and divergence and convergence. No, it is not that complicated. The only thing which you need to understand here is that in previous examples, when we were finding x1, x2, x3, we were getting basically closer to our root. And what was the clue? We basically ended up getting as same x's till a particular decimal place. Okay. But here we can see that our x0 is 2 and x1 is 5. Okay, these are close enough. X2 is very different and X3 is very, very different. So this means that this iterative formula is basically a divergent sequence. So it is not possible to find the root to two decimal places with x not equals 2. And the question I wrote before this example, which was not a mathematical question, but it was a logical question. And the statement was, I'll repeat the statement again. Is there any relationship between the iterative formula chosen and the root to which it converges? So yes, certainly there is a relationship. This iterative formula is a divergent one. The ones which we have discussed before this example, all of those were convergent sequences. So in those cases, we were able to get our x approximately, but we were at least able to get it. But here, since our iterative formula is a divergent one, so we would never be able to get our root using iteration method, right? Okay.
Okay.
Did you understand this thing?
Yes. Yes, it's fine.
Okay, perfect. So we are done with this chapter finally. Let's just summarize everything. Okay. So yeah. So the very first thing, which let's just talk about the summary of this chapter now. Okay, let me take the summary. Okay. So the first thing we saw in this chapter was to find if the root would exist or not. We did not discuss how to find the roots other than the iterative method, but yes, we discussed if the root would exist or not. Okay. So let's say if this is the question and this is your interval, and the examiner wants you to tell if there would be a root. First question is, what is root? Root is basically the value of x at which function is 0. So basically, the x which is satisfying this equation is the root, right? So we find f of a and
Yes.
we find f of b. So it could be that it is positive, it could be that it is negative, or either way. And the only thing which we had to observe in the first section was change of sign. And I told you to learn this statement, you will have to write it because this is basically the explanation or justification of your concept. Okay. So are you clear with the first
Okay.
one?
Yes.
Okay. Then we discussed how to plot some graphs like for quadratic functions. We discussed that if the most basic version is y equals x squared. So if this is y equals x squared, the graph for y equals x minus 1 whole square would move to which side, Ranjani? To this side, to the right side, or to the left side?
To the left side.
To this side? Are you sure? Think about it once
It's
again.
negative, right?
Yeah, and but look, where's the negative sign? Just notice that.
Wait, what? It'll be on the
Okay.
right side.
Yeah, it will be on the right side because whenever we have x minus 1, I told you this, think of it as a negative relationship, okay? We have minus, so it would move
Okay.
towards the this side. Okay, let me give you a good example. Okay,
Because it'll be -1 square, right? So
yeah, yeah. So the stationary point would be
okay.
this one.
So it'll be positive.
Yeah, because when y is 0, think about it this way. When y is 0, x-axis is all about when y is 0. This is y, so this is y0. So this whole line is y equals 0. So when y is 0, our x would be 1, right? 0 equals x minus 1
Yes.
whole square. This would be x minus 1 equals 0. So this would be x equals 1. So this is going to be our vertex and it is positive. So it would be in the upward direction. And I want you to tell me this value. For this value, you will plug x equals 0 because at the y-axis, x is 0. So this would be 1. Okay?
Okay.
Right, Pranjali? Are you clear with this? Tell me honestly.
Yes.
This is why I'm revising
Yes.
everything. Okay, perfect. Then once we discussed some graphs, linear graphs, quadratic graphs, cubic graphs, then we saw that where the change of sign method fails, right? For example, in the in case of f
Tan
of
graph
x,
and 1/x.
excellent, excellent. Okay, and then finally we talked about Our today's class, we discussed the next topic today, that was iterative method. So let's talk about it. Okay, let's talk about only this method. I would like to revise it properly. So we discussed iterative methods today. First question is, what are iterative methods? It is basically a method to find the root. We know different methods. This is also a method. Okay, but this method is not a preferable one because it is time taking. It is not necessary that you get your x. It could be that the sequence is divergent. Okay, all right. So you have f of x equals 0. You need to get your x equals g of x form. Once you have x equals g of x form, you need to add n plus 1 and n here, and simply x naught, you need to have your starting x naught. Either you would be given or you would have such an interval in your question. So this would be your x naught. Okay. So we have, once we have x naught, we can find x1. How can we find x1? Because x1 would basically be g of x naught. And once we have x1, we can find x2 and so on. And then we will end up getting a root. And what is the clue? What is our stopping point? In question, you would be given a particular number of decimal places for your answer. So you will find different x's, and there would be a point where you will see that, let's say, your value is, you're getting same value after till the two decimal places or three or one. It varies from question to question. Okay. And this is your stopping point. So you can clearly write that your x is 0.45. Okay, this is the case in every question, in most of the questions, not every question, in most of the questions, but it could be that your iterative formula or sequence is divergent. Don't get confused by this word. The only thing you need to know about this word or this thing is that you would not end up getting such a situation. You will not get such a situation. We just discussed in previous example how our situation would be in this case. You will continue, you will try finding x's. It could be that you end up finding x12, like you go till there. So far we have just calculated till x4. But in case of divergent, it could be that you continue doing it till x12, and even then your answer is not coming same. So that is your clue that it is your iterative formula is a divergent one. Hence, you would never be able to find your roots this way. So are you clear with this?
Yes.
100%, because we are done with chapter 6, and from tomorrow we will start stats.
Yes, it's clear.
Okay, perfect. So I'll stop the recording.